In this video, we're going to be going over examples of identifying whether or not a relation or an equation is a function. For my first example, I'm given a relation 1, 2, 2, 5, and 7, 16. I would always recommend listing out your domain and range in order to identify whether or not it's a function. So my domain, again, are just my x values. In this case, it is 1, 2, and 7. My range, which are my y values, are given as 2, 5, and 16. In order to identify whether or not my relation is a function, I'm strictly looking at my domain, checking whether or not any value repeats. I see no value repeats, therefore it is a function. In my second example, I'm given a different relation. I have the coordinate points 1, 3, 7, 9, 2, 15, and 7, 10. Listing out my domain, I have 1, 7, 2, 7. For my range, I have 3, 9, 15, and 10. Again, I'm strictly looking at my domain. Notice I have two values, 7, that show up in the domain twice. Therefore, this is not a function. Let's do an example with equations. So here we're given an equation x squared plus y squared is equal to 1. If you were to graph this, you would get a circle. If you were to graph a circle, in terms of a graph, you can see whether or not a graph is a function. But we'll talk about that later. Say we have the equation x squared plus y squared equals to 1. When you are trying to determine if a function is a relation or not, I would recommend solving for y. So let's solve for y and see what happens. So we're given x squared plus y squared is equal to 1. To solve for y, you obviously want to get the x away from the left side. Because x squared is being added to y squared, in order to get rid of it, I can subtract x squared on both sides. X squared minus x squared is 0, so I can cancel them out. I'm left with y squared is equal to 1 minus x squared. Next, I have to get rid of that squared. The inverse of the squared is the square root. So I square root both sides. When I do that, I'm left with y is equal to plus or minus the square root of 1 minus x squared. Where did this plus or minus come from? Well, just a side note, whenever you're squaring, rooting, or even rooting any function, you have to add the plus or minus, because in other words, a value squared can be either the positive or negative of that value. In other words, 2 squared is equal to 4, but negative 2 squared is also equal to 4. So that means the square root of 4 could either be positive 2 or negative 2. So you have to take into account whenever you're even rooting a value, especially when it's negative, the output will be positive. In this case, my output is positive, but my input could have been either positive or negative 2. We do not know, so we always make sure to specify it can be one or the other. Here, we are given that y can be the plus or minus of a value of x. But how can we tell if it's a function? So what I would recommend is we can make a table. So this is my x and this is my y. Obviously, we're going to pick random values of x, it does not really matter, and input it to get my y. So let's say I choose that x is, I'm going to plug in 0 for my x, and I'm going to plug it into y to identify the solution. So this becomes plus or minus the square root of 1 minus 0 squared. Simplifying this, I have the plus or minus square root of 1. And we all know that the square root of 1 is just itself. So this is plus or minus 1. What this means is that my value of 0 gives me two values of y. This would mean that if I were to write a coordinate point, I can write it either as 0, 1, and 0, negative 1, meaning my domain of 0 repeats itself. Therefore, this is not a function. This also lets me know, or especially this plus or minus, lets me know that for any x, there's a positive and negative for y. Now, let's do another example. Say we have x squared plus y cubed is equal to 1. Solving for y, I'm going to subtract x squared on both sides because the x squared is being added to the y cubed. My x squared, positive and negative, because they're opposites, they can cancel out and they turn out to be 0. I'm left with y cubed by itself on the left, and I'm left with 1 minus x squared on the right. In this case, I want to cube root. So I cube root both sides of the equation in order to get rid of the cubed value of my y. Now, when it comes to odd roots, you do not put the plus or minus, as the output matches the sign of the input. So y is just equal to the square root of 1 minus x squared. Side note, so for example, if I had 2 cubed, this would equal to 8. But negative 2 cubed gives me negative 8. So if I'm looking at the cube root of 8, it can only be a positive 2. But I'm looking for the cube root of negative 8, it can only be negative 2. So I do not need to put the plus or minus. Back here, again, we can do the same thing as we did earlier and input values to solve for x, in order to solve for y, sorry. So if this is my x and this is my y, let x be 0. Plugging that in, I have the square root of 1 minus 0 squared, which is just the square root of 1, which is just 1. So my only value in my relation is 0, 1. The domain does not repeat, making this a relation. This is how you categorize a function. This is how you characterize a function or an equation.